July 26, 2011. And then the camera's recording, it looks like it is. We're going to be demonstrating the gasoline arc gap on this system of embodiments of the wireless Tesla coil. Right now I've just turned the machine on. There's some gasoline, a needle, and an air gap here. I'm not real familiar with the rehearsal of the camera. It might be touching the gasoline. It'll probably just go into flames when this starts there. But to understand then, we got, can I keep the background down, you know? Trying to do work here. I got 100 volts there from the unenergized field across that apparatus. Gasoline itself is a dielectric, so it should be treated as an insulator. The bottom arc gap, we have some 250 volts, and all we got to do to enable the bipolar Tesla coil system to be activated is to cause arc gaps there. And there's our poles. And we've had problems facing the sunlight. We'll have to close the garage door when we look at it and that. And the system has evolved. Here's the idiot club. They won't quit talking. Okay then. We got a transformer, a 4-to-1 transformer on the bottom phase 1. So we're just going to go ahead in there, turn the system on, and focus on the gasoline arc gap, and we'll see what happens with the gasoline arc gap upon ignition.
I think we ought to call kindergarten.
No, there we go. There's our input conditions. And then there was something I wanted to comment about the input conditions. Right now it's rating 0.5 volts on the phase going to the transformer. It's being loaded down. The phase 2 is 1 volts, 1.1. Phase 3 has 0.9 volts. Those are the yellow voltmeters to the upper left, bottom, and right. And the stator line amperages are listed, and those are the conditions of the circuit prior field energization. Now we'll go ahead and turn the field up and go back to our inputs, but first now then we'll look at what the gasoline arc gap is going to do. Now this is the first time for us. We wanted to make the documentary before we do this now, huh? You know, I think the camera might even give us some justice here. And I'm going to go in there and turn the field on and know what goes on. Oh, we're going to take the meters off. Good Lord. Never forget to do that, folks. Them damn meters up there, let me try. Not damn sure about that. Those meters out of there. There's 0 volts on both of them. We'll leave them on anyway. We're at 10 volts. We're at 20 volts. Step down 4 volts. We're at 30 volts. We're at 40 volts. No, I would not. It does not appear that we might not be getting any arcing into that gasoline. It looks like we might. This is the camera there, Jim. Do you think you see anything? I'll be diggity dog. It don't appear to be working. We need some more fuel, Jim. We're going to turn that off momentarily.
Hey,
come on, guys. Fine looking here.
No, the vapors what ignite.
There's nothing happening.
The vapor.
The needle's too far away.
But the vapor. Yeah, we're going to catch the vapor.
Just put a bit spot in for it.
Yeah, put about 8 gallons in there.
Okay, that's good.
Then he has the gasoline on.
Okay.
Yeah, Mom got it.
Well, try that again then.
Hey, you don't have research laboratory insurance.
Looks close to me. I don't know what's wrong.
Hey, you don't carry research laboratory insurance.
I still can't see nothing. There ain't nothing happening. In the camera you can see a little bit of fluid movement. Watch yourself, you might get shocked, Mr. Okay, so much for that. I think it is hitting, camera shows it's hitting something. It's that electric field's doing something in there, and it ain't igniting or nothing. Oh no, what's the camera's doing? Oh, my voltage meter's gone crazy. Okay, let's end this right now. Let's show right now. Come back in there. Be quiet. I'm trying to do this. Okay, there's our secondary action. That's not a bad secondary action. Green there. And now we want to look at our input. Close this out. Notice our high amperages on the stator line. Notice the amperages involved on the phases themselves. Notice the voltage on the phases themselves. Later on I can explain this as a kind of transformative effect where when you're going to create a phase with more voltage, for example right now phase 2 has 4950 volts, phase 3 has 18 volts, and phase 1 only has 3 volts. Okay, well, the amperage distribution involved there's a transformative thing that can be explained, and we'll let this video go for now. Thank you. So one last shot. Here's the primary arc gap. And we might have a pop from that gasoline arc gap, but that's disappointing. And we do have secondary arcing, but it can't be seen in just the sunlight. Thank you.